So this is my first slide, just because it says my name. I didn't go to Berkeley, which congratulations on that. I'm actually a high school dropout. Graduated high school when I was 15. Started working in technology, worked at AT&T, worked at Southern California Edison. Started working in media and entertainment when I was 18. I started at NBC Universal, was there for 13 years. Left there, ran a TV production company for North and South America, working on all sorts of interesting problems with content and retention and really bridging the digital divide between the content itself, which is living in the real world, and bringing in aspects of technology. So I worked with startups that a lot of them came out of Launchpad, did some consulting with those guys, helped them kind of mentor them to understand what the media space was like, how to use the space to launch their products. So worked with companies like Pop-Up Pantry and worked with companies that really came out of that space. Beyond that, I also started 2 startups. I have patents in digital advertising. One of those companies is still up and running, so customers like BBC, ITV. I own all of the post-production workflow for the Nordics. Turns out there's 2 post-supervisors, so if anybody's familiar with that, it's not really that impressive. But anyway, the point is that we're going to talk about machine learning, AI, computer vision. Barbara here was nice enough to kind of give us a nice primer on that. I do have some code in here, so you guys will be riveted by that, I think, as well. But what I want to do is I want to start off by talking about kind of the application of machine learning and computer vision. So I'm just going to play this relatively quick video, if it plays.
I'm Saqib Sheikh. I lost my sight when I was 7, and shortly after that I went to a school for the blind, and that's where I was introduced to talking computers, and that really opened up a whole new world of opportunities. I joined Microsoft 10 years ago as a software engineer. I love making things which improve people's lives. And one of the things I've always dreamt of since I was at university was this idea of something that could tell you at any moment what's going on around you.
I think it's a man jumping in the air doing a trick on a skateboard.
I teamed up with like-minded engineers to make an app which lets you know who and what is around you. It's based on top of the Microsoft Intelligence APIs, which makes it so much easier to make this kind of thing. The app runs on smartphones, but also on the Pivot Head smart glasses. When you're talking to a bigger group, sometimes you can talk and there's no response, and you think, is everyone listening really well, or are they half asleep? And you never know.
I see 2 faces, 40-year-old man with a beard looking surprised, 20-year-old woman looking happy.
The app can describe the general age and gender of the people around me and what their emotions are, which is incredible. One of the things that's most useful about the app is the ability to read out text.
Hello, good afternoon. Here's your menu.
Great, thank you. I can use the app on my phone to take a picture of the menu, and it's going to guide me on how to take that correct photo.
Move camera to the bottom right and away from the document.
And then it'll recognize the text. Read me the headings.
I see appetizers, salads, paninis, pizzas, pastas.
Years ago, this was science fiction. I never thought it would be something that you could actually do, but artificial intelligence is improving at an ever faster rate, and I'm really excited to see where we can take this. As engineers, we're always standing on the shoulders of giants, building on top of what went before. And in this case, we've taken years of research from Microsoft Research to pull this off.
I think it's a young girl throwing an orange frisbee in the park.
For me, it's about taking that far-off dream and building it one step at a time. I think this is just the beginning.
So that one gives you all the feels that you need. I want to talk about what this is based upon. Obviously, this is one application. That's a real-world application that's actually built out in the wild. That's something that we've built in-house through a number of engineers at Microsoft. But what he's using is using a number of our APIs that are based on our computer and machine learning and computer vision. So he's using vision, speech to text, text to speech as well. That's what the Cortana voice is coming back with. He's using a natural language interpreter, which are always available. And then we have Bing Search, which is our knowledge API, and actual search itself. I want to focus in on this really cool transition, as well as talk about vision. things that the computer can actually see and understand. We want to interpret these things, not necessarily just for ourselves, but really to kind of understand and create metadata. And what's the purpose of metadata? What are we going to do with it? So here's an image. The first image is clearly about a 27-year-old male. Gender, obviously, is a male. And we're going to get back information. So we're going to make a request. We're going to send up a video or a photo. We're going to ask for the computer vision API to make an estimation on what it sees. It's going to return a bunch of information. As you can see, I told you there was going to be code. This is what you get. It's all JSON. And gives you additional metadata information. Now, what's the purpose? Like, what are we doing with this? So, from a media perspective, this is what I'm keenly interested in, is I want to be able to understand what's in a frame of video. If I'm accepting UGC data, I want to make sure that I understand who's in the video, what's in the video, start creating metadata tags so I can then personalize for that individual. So if I have a content library of, 8,000 hours of content, I don't have to have a logger go in and view 8,000 hours of content, or 5 loggers, or 50 loggers, or 100,000 loggers, however many people it takes in order to get that. Reduce the cost of creating metadata. Then, let's now apply that to what happens today. You guys go to YouTube, you type in a tag, what do you get? You get results. All that's metadata. How do you find that stuff? Well, now, I can actually give that same power to anybody with a content library that was never able to personalize anything that they had before. So take Warner Brothers, or Disney, or where are we in downtown? So anybody shooting at LA City Studios, any of those places, anybody can now take this content and then run it against their stuff and then start creating personalizations. So that day when you open up your app, more than likely it's going to be Google Maps. You're going to type in where you're going. Google Maps is going to send that to your car, and your car starts driving. You have nothing but free time in the vehicle. I know who you are, where you're going, how long you're in the car, and I know a lot about what you like. So now I can start serving advertising that makes sense to you. I can start serving content that makes sense to you. This is going to change that aspect of your overall lives. What else can I do with these machine learning APIs? I can start detecting emotion. I can start to figure out how the person in the video is feeling. This is our face detection. Based upon cues, based upon the pixels themselves, I can start to kind of figure out, or at least make an estimation on how a person's feeling. From a media perspective, I can start to find emotional points. So I can start to cut and edit videos that are based upon these emotions to give you the feel that I want to give. But equally, if I'm ingesting hundreds of thousands of hours from security cameras, closed caption TV across the entire world, I can start to look for suspicious acts. Somebody mentioned person of interest. There's this is basically what that is. I can also detect faces, right? So I can detect emotion, but I can start to detect faces. So I know this is a person. We have created a database that contains about 10 million images of what we consider to be celebrities. There's about 300 celebrities in there. This is Jasper Williams. Don't know who that is, but that's who we decided. Nonetheless, the point is that I can take this video, the frames of video, the content back library, and run it against these APIs and find out who's in that video. So if I want to find all the videos in my content library or in my DVD library of Tom Cruise, I have a fast and easy way to create that. So let's talk about application. This is what we decided to do with all that. We have the entire computing power of the entire internet available to us, and we created a website called What Dog. The idea is that you upload an image, specifically of your dog. We try to figure out who that dog is. You have a poodle, you have a German Shepherd, and we upload that, and we tell you that information with relative success. Really, the outliers of what's more interesting is when it's not that. That's what's really more interesting. But what's also you can do with that is you can upload any image. So, I myself, golden retriever, it's obvious, it's a beard. But Joe here, Joe's a staffy. I just lost mine, but that's really what it's doing. It's looking at the pixels, it's trying to make an estimation, it's trying to guess who you are based upon the information that it has. The upside is all this is trainable. So now what we released at our build conference about 2.5 weeks ago is now you can take all this data, you can take all these images, and you guys can create your own subset of data. So if you guys had 100,000 images, 200,000 images of stuff that you guys wanted to find out, I can show you where the faces are, and you guys can then tell me who it is. And so your very next time that you run that against your video library, you now have that information coming back. Your data, your metadata becomes richer and richer. And that's just part of our custom recognition. We have custom recognition not only for video, for images. Essentially, if you think about what a video is, it's just a number of stills. So we'll take a still, upload it to our system, we'll then get back that information. But we can also do that with speech. And again, wonderful transitions. This is what we pay for. I can now create models. So you talked about Alexa, right? So Alexa has a very vast data set of understanding. So when you talk to Alexa, it knows what you're saying, what you're doing. That's great when you're talking about just kind of standard conversations. I was having a conversation with somebody earlier about medical and pharmaceuticals. Well, there's a lot of words there that aren't in necessarily the English language, right? You know, you're going to talk about different things that aren't in that data set. So if you want to make your data set or your conversational application richer, you have to create these custom libraries. And we're doing that with both speech and video. We also do text analysis. Again, we're going to go out, we're going to use our large data set of information, and we're going to then start to analyze what's being said and weighting. Somebody mentioned weighting the text that was coming back. So now we're going to weight that text, and I'm going to then create sentiment based on it. Is this happy? Is this sad? Is this negative? Is this positive? I'm going to be able to send that back to you again. We're using it for very similar ways. You use it for sentiment analysis against Twitter. So if I'm a brand, and I want to know what people are saying about their product. Microsoft just launched a brand new version of XYZ. I want to suck in all of this data from Twitter, Facebook, even our own search engine, which you'd be surprised to hear, 30% of searches are done on beta. Don't be shocked, that was what I heard. You guys don't really think about it, but Facebook search, AOL, which I'm pretty sure my grandma still uses, Yahoo, Siri on your phone on the back end is all using Bing. So you're using Bing, you don't know it, but the data set's really, really rich. Granted, it's not 70% of the market, but still it's 30%. We're able to take that information and create all the sentiment. We can extract key phrases, so we can start to do, this is based upon our search, right? There's nothing crazy there. But we can start to understand what people are saying, grab that sentiment, and then combine it all together to give you the results that you're looking for. Equally, topic discussions. So we'll take it all and keep it contextual, so now we can have a conversation going. So when you start to create bots, the biggest problem with bots, so you have all your intents, but those intents are singular, right? Tell me the weather. Tell me the game score. Tell me this. But if I say, hey, what was last week's score? The bot itself will have no idea. So now if I can take all this information and keep it contextual, now I can go up to a bot and say, hey, what's the weather? And it knows I'm not talking about LA because I was just talking to it about San Francisco because it knows I'm on a flight. All this ends up being contextual and it keeps topics together. I'm going to skip through some of this. This is, voice recognition. I can recognize both speech to text. We have two interpreters. We have Lewis, which is our language interpreter, so that's just straight speech to text. Then we have something called Chris. Chris is our custom recognition, so you can then train that model. Again, this is all your data. You guys do with it as you will, but the point is that I can then start to take people that have speech impediments, people with children. Children are really difficult because they have stutters, they have different dialects. We can take people that aren't native English speakers and then train those models based on these things. And then we can take it the opposite way. We can then synthesize content. So I can take speech to text and then text to speech, and that's where Cortana comes in. And you want to talk about assigning personalities, you want to talk about assigning kind of conversational things. I can create a voice that's completely synthetic, but because I have sentiment analysis, I can then, you ask me, hey, what's the score? I can give you that same either enthusiasm, I can give you that same kind of response back that you're typically related to when you have interactions with human individuals. And then I can obviously get intent. I'm going to skip some of this. This is from another thing. Anyway, all this together puts together a large set of tools that are available to you. You no longer have to build the tool sets yourselves. These are built in the build. We're constantly working on these things. The idea behind having to create your own model, having to create your own program that's living in Amazon. We bought a company called Revolution. We've built a platform so you can actually build your own model against your data. The availability and the amount of power that we're putting behind these things is pretty vast. The idea for you guys is to utilize our services to make whatever's best for you. Our training models are yours. You're welcome to share them back to us to make our models generally better, but they're your data. You do with them as you will. So that is how Microsoft's using machine learning AI to kind of make our lives better. So I appreciate everybody's time. Feel free to email me if you have any questions.